Okay, here again, this is Nick, and we'll be continuing on the series of videos about physical science. This time we're dealing with measurements in physical science, or measurements in physical science. Okay, these are measurements of all. They are measurements of all forms in science. That's what distinguishes science: the fact that there's constant measurement, and that's what helps to make um, science a very authentic discipline. Although the problem that we're going to deal with here is not necessarily the issue of measurement. It really is about precision, accuracy. It's about uh, being able to solve the problem of accuracy, because in measurements there is no such thing as an absolute accurate measurement. What happens is that we get scientists or individual participants get it's close enough, and at some point they have to agree that this is actually the measurement, and they work with that measurement. Okay, so it's a matter of close enough to what might be perceived as the correct value. All right, so we must understand that there is no such thing as an absolutely accurate value. Instead, we're getting close. We get close to understanding what value are we going to use. Okay, let's see. So distracted there. All right. For example, someone could say that the answer to a measurement is 56.8 meters. Yet another person could say that is 56.84 meters. And a third person could say that is 56.842 meters. Now, all of these answers could be correct, but it depends on what the parameters are. What is it that you're asked to do. Um, so, when the parameters are given, and one of those parameters is the whole issue of significant figures. And I'm going to be talking about significant figures a little later on, right? In the above example, if we follow that rationale of trying to get the correct number or correct answer, uh, we could end up with a series of correct answers. So at some point, we have to sort of cut it off, you know, curtail the answer to try and get one number with which we can work. But notice that no one is saying that the answer is 54.00. If someone genuinely believes that the answer is 54.00, in science there's also an explanation for such incidences. Okay, for this reason, among others, there is a concept called significant place, or significant places, or significant digits, and this helps to limit the possible numerous uh, answers to get to a more acceptable answer. Okay, again, the idea of significant figures, significant places is one of the first parameters that will be discussed. Now, this introductory video is going to take a look at some instruments that we use in the physical sciences. Um, to give us a general idea of how measurements are taken. And it will also help you to understand why is it that different individuals can look at the same phenomenon or the same measurement and come to different conclusions. This is certainly not uncommon in the physical sciences. But again, it must be understood that the exactness and precision is really not a big problem, but instead, science has systems built within itself to to solve those problems. To solve those problems. So I will spend some time showing you some of those instruments. The first one we have here is a ruler. Everybody knows what a ruler is. We have ruler. This is a ruler that is divided into inches and centimeters. Okay. Of course, then you have rulers that are subdivided into millimeters. And the smaller the unit, the closer you get to an accurate number. The most accurate number. But sometimes you're really not interested, depending on what you're using, what you're measuring, you're really not interested in going so small, you know, and sometimes you're not interested in using the larger numbers. So it all depends. Again, those parameters, what is it that you're doing? Here is one that has millimeters. Obviously, it is very, very small. Now, there's a difference between using a ruler looking like that and a ruler looking like that. If you use a ruler that looks like that, or if you're having problems with your eyes, it would be very difficult for you to tell what number you're dealing with. But as the ruler gets bigger, it's easier for you to see the subdivisions of the numbers. And here are some other examples of rulers, and you will encounter several rulers. Many of them will have different different units on different sides, and this is a typical one of them. Here is a ruler, but it does not have any any numbers written on them. So this is one of those things that you can use to improvise. Notice that these spaces, the intervals between these are the same. Okay, and intervals here are the same. That's one of the things that you have to do if you're improvising. You got to make sure that there is some consistency along the measurement lines. Okay, here we have some volumetric cylinders, measuring cylinders. Okay, from 50 to 1 liter or 1000 ml. Uh, here you have another shot of them. They're going up and by the way, it the measurement that you get in the 10 ml is usually more accurate than the measurement that you'll get in the 2 liters. And the general idea is that as the meniscus, and we'll talk about the meniscus in a while, as the meniscus gets smaller, it's a more accurate measurement that you can get. All right, here's the meniscus. Meniscus. This is the meniscus, which is, see, this curve. This curve is called a meniscus. Sometimes you have a curve that looks like this, like in the case of mercury thermometers, where the surface tension is a little different. Mercury is really a solid. I mean, sorry, is a metal that is in a liquid state, at room temperature. So it would look like this. So don't be surprised if you see some liquids like that. Of course, this is caused by surface tension, which is a completely different topic. Um, but you have to get to eye level and look underneath the meniscus. But the question is the measurement underneath the meniscus or somewhere else? Uh, Again, I guess is the wrong way of looking at it. So you can't look at it standing up like that sometimes, or you can't look at it sitting down sometimes. You might have to be somewhere in the middle there so you can see exactly where it should be. Okay, so here's another example where this is being amplified. You can see here that it looks as if it's somewhere around 35, but over here now you're beginning to see 36, 37. Okay, so here we have a triple beam balance, and let me just show you up close. In a triple beam balance, then you have these numbers. This one goes from has intervals of 100 grams. So this is the one. If you place it here, it's 100. Right now it's at 300. So if you place it here, it will be 200. Okay. This one here now goes by tens. So it's 10, 20, 30, 40. And this one goes by ones. So this is 3, 4, 5, 6, and so on. So where this the point here right here is we have 3, 3.1, 3.2, 3.3. But it's a little bit above 3.3. So you could say that it's about 3.35 or something like that. See? So those are the types of measurements that you or measurement problem that you could have when you're dealing with these types of things. Okay, this is a beaker. This is a beaker that has 100 ml. Of course, this is drawn a bit incorrectly because you should have a slight meniscus here and a slight one here. This doesn't seem to have any meniscus at all, but that is not how it happens in reality. Another beaker here. This beaker is but notice here, it goes up to 500 here, but it does say that it is a beaker that is 600 ml. Okay, that is very typical, very typical. So to get the 600, you'll have to go in further up. So don't be surprised about things like that. And this is an Erlenmeyer flask. These are flasks. Again, the flasks and beakers are not generally used to get accurate measurements. We usually use the volumetric cylinder or the measuring cylinder. Those are the ones that provide more accurate measurements. And these are pipettes or pipettes. Uh, these measure very small amounts, but more importantly, it's not just about the small amount. It's the way the material or the liquid has to be transferred. And a pipette or pipette, depending on how you say it, um, is very convenient at times. So that is something that you can do. Let me just show you another shot. This is another one, and it's like a dropper. It's like a dropper. Sometimes when you want to just get a very small amount, you could use a dropper. So a pipette or pipette is used to transfer information, transfer a liquid in that form. Okay, so in this video, I went over a certain number of measuring devices. These are common measuring devices. We have many more measuring devices in the physical sciences, but these are the very common ones. In the next video, I will begin to speak about numbers, and I will start with certain and uncertain digits. Okay, that's before we get into significant figures. Okay, well, again, this is Nick. Thank you.